So here's an interesting homework problem related to something we might find at the store. So generally I see two different size avocados at the store. The smaller one, let's say that's the regular one, is usually cheaper than the larger one. And then the question is, well, are they the same deal? Like, is one a better deal than the other? Well, what does that mean exactly? So we know the regular one sells for 85 cents. What prices would be good to make the bigger one a better deal? Well, how much bigger is the bigger one? So you could whip out a ruler, which is what I did when I first saw this, and held the ruler up to my screen to measure them. And since we all have different size screens, we're not going to get the same measurement when we measure this particular picture. At home, I whipped out an avocado. I have a regular one at home, and right now I see the avocado in my hand, like the regular one, is about 6 centimeters across. The other thing you can do if you don't have a ruler nearby, just hold a piece of paper up to the screen. So I'm gonna say, here's my piece of paper, and I just wanna measure across and make a mark on my paper where this starts here and where it ends. And let's just worry about the width and not the height. And then I could do a similar thing for the big one. I could compare, I could slide, whoa, pen's a little crazy there. I could slide my paper across, maybe starting at the same spot that did, and measure across and see what I get. So I would measure from here, across, and I can see the blue line is definitely bigger than the red line. And if I put them on the same piece of paper, starting in the same spot, I can see how much bigger. So here, I'm just gonna pick up that red line. Oh, that's not the red line. Let's try that again. The red line? Nope. At the red line. Nope. Oh, come on, give me the red line. All right, this is trickier than I thought it would be. There it is. All right, I can move that over there and I can compare the two. All right, so how much bigger is it? So from here to here is how much bigger that is. So there's lots of ways we can guess at that right there. So I'm gonna maybe break this in half and then in half again and say, well, if I consider the red line now has 4 pieces, that looks like about one of those. So I'm guessing that it's like maybe 20% to 25% wider. So does that mean the price should be 20 to 25% more? Well, an avocado isn't like a piece of string, so it's got 3 dimensions. So I really need to think about not its width, but I should think about its weight or volume. Now, I can't weigh these because I only have a picture, but I can estimate the volume of them. So let's look up some information about volume. So there's a lot of times when I'm trying to solve a problem and I got to do some research. So I just searched for volume here, and there's a definition of volume there, some pictures of volumes with formulas. I find Wikipedia is a good source. I'm going to go there. All right, so yeah, we could do volume like cups and ounces and stuff. That's not quite what I want. Let's look on down here. History of volumes, thank you very much. Graduated cylinder. All right, so often we measure volume in cubic things like cubic inches, cubic feet, cubic centimeters, in addition to things like gallons and quarts. And then there's all these different shapes. So which of these basic shapes is an avocado most like? I'm going to say it's most like a sphere. I'm going to go for that one. So let's see, sphere. 4/3 pi r cubed, where r is the radius. All right. Let's write that down, see what we can do with that. So if we say an avocado is like a sphere, we now know the sphere volume is 4/3 times pi times the radius to the third power. Now, when I drew these lines across, I was estimating width as in diameter. And just remember that the radius would be the distance from the center to the edge. So that would be a radius there. So I want the radius, which is half of the diameter. All right, so what do I call these volumes? Well, I could do what I did before and say, well, the one at my house was 6 centimeters wide. So then I could estimate how much wider that one is. So if I say this one right here was 6 centimeters, And you could pick a different number if you want to make it easier. We could call it 1 across if we wanted to. Let's say I call that 6 all the way across. So then halfway across would be a radius of 3 for the little one. And the big one, I was thinking was like 20 to 25% bigger than the 6. So what would that be? Half of 3 is 1.5. All right, so then I would guess that this thing here is 6 plus 1.5, which would give me a diameter of 7.5, right? I got that by taking the 6 and I added a quarter of 6, which is 1.5. That's that 1.25 wider. And so the radius would be half of that. So 7.5 over 2. And then it's calculator time. If you can do it in your head, awesome. Do it on a test. Always write it down and put it on your calculator. So I'm just going to whip out my, do I still have Desmos here? Yep. And let's see, how about 7.5? Was it what I think the big diameter might be? I'm just cut that in half, 3.75. All right. So I think the big one is 3.75. So 3 centimeters versus 3.5 centimeters. And now I just want to compare their volumes. I think I'll make, say, a table here, where I've got a radius and I've got a volume and I've got a thing. So I got the small avocado had a radius of 3. And then I have the big avocado, which has a radius of 3.75. And then I want to calculate the volume. So 4/3 times pi times 3 cubed versus 4/3 times pi times 3.75 cubed. All right. Calculate a time. Well, this might be a good place for a spreadsheet. Do it both ways for fun. All right, so 4/3 times pi times 3 raised to the 3rd power. All right, so that's the volume of the little one. 113-ish cubic centimeters. 4/3 times pi times 3.75 raised to the 3rd power. Ooh, it's almost twice as big, even though it's only like 25% wider. If we have a diameter for width, the volume, it's got like twice as big. Then you think, oh, but what about the nut inside? Ooh, I don't know. We're going to ignore that. We're just going to go with the overall volume because we don't have a way to check how big the nut is inside. Almost twice as big. So I could like make an estimate. So if the first one's 85, twice 85 is what? 2 times 85 cents would be $1.70. And just double check, right? If you double 113, what does that give you? 120, 226. So it's not quite double. The big one is not quite double. All right, let's put this in our notebook. Let's go to just one decimal place. So 113, or not, let's go to no decimal places, 113 and 221. All right, helps to write things down to think about. So this one here is 113 centimeters cubed, or cubic centimeters, and this one here was 221 cubic centimeters. So almost twice as big. So if this one had a price of $0.85, a comparable price to this one would be just under double. So just a little less than 170. So I'm just going to guess like maybe 165 would be about the same price per ounce or something like that. We can double check that. So if we want to double check a comparable price, then we would set up a proportion. So I would just compare price to volume. So I know the price of the regular one is 85 cents, $0.85, and I know its volume is about 113 cubic centimeters. I want to know what the price should be the big one so they're equal when that one has a volume of 221 cubic centimeters. So again, this is the regular avocado here. This is the large avocado here. And if I just cross multiply that 221 up, then that tells me my missing price is whatever the 0.85, right? That's dollar per volume. Oops. Ah, right. So price per volume times the 221. All right, whip it out in a calculator. That'll give me a better estimate of what the big one ought to cost to be a fair price. So let's get rid of the 2 times there. Let's take that 0.85 and divide by the 113, and then multiply that by the 221, and I get a comparable price would be $1.66. Right, if I'm talking about cents, 166 cents roughly. So my guess of 165 was pretty close. So anything under that, and then the big one's a better deal. Right? So that's kind of cool. So any price less than, so this came out to be about $1.66. That's a 6. So anything less is a better deal compared to the 85 cents for the small one. And I do hope you write down work like this when you do your homework, especially when you do your quizzes, if you want to submit work after you do a quiz, if you don't get the problem right the first time. All right, good luck. Do good math. See you later.